Amazon Web Services provides lots of online tools that we can use to analyze data and do other countless wonderful applications of technology. But the one I'd like to talk about today is Amazon Machine Learning, which is a cloud-based platform for predictive modeling that makes it easy to construct models, analyze them, and evaluate their efficiency. So some of the things that we're going to talk about today are, we're going to start by going through the tutorial that they have provided and discussing the key concepts, the process to create a Amazon machine learning model. Then we're going to continue by talking about the evaluation that provides and discussing some more potential applications of the web service. To the Amazon Web Services tutorial that they have provided for the Amazon machine learning functionality. So the first step is they're going to have a sample data set that we're going to be analyzing and trying to predict some values for a banking set. So in their example, what you want to do, and in ours, what we ended up doing is you upload your data set as a CSV into the S3 web service that Amazon also provides, which is just it's a data hosting service. So then later it'll be easier to reference because there's no inter-service overlap and trouble. So once you have that uploaded to S3, you can start by creating a data source. So what a data source is basically a reference to your data set. It doesn't actually store the data when you create a data source. So if you move where it was originally, then you'll have to re-reference it. But basically here you can specify a few things, in particular the names of the attributes and which type each one is, whether that is, again, numeric, text, categorical, or binary, because those are all, again, processed separately, as well as the target that you're going to be trying to predict. So in order to do that, what you do is you go to the Amazon machine learning page and you create a new data source right here. You specify where it is located. In our case is S3. So you indicate the bucket name and then the actual file, and you can name it. So lastly, you have to provide permissions in order for Amazon Machine Learning to interact with the S3 module. And we can continue by creating the schema, which is where you establish which type each variable is and declare all the names. So if you have your first row as all the variables in your original CSV, you can indicate that and it'll automatically put in all the variable names. If not, you can continue by going ahead and setting each variable type to the corresponding type, which is, again, either numeric, categorical, and this is all done in creating the data source. Now the next step is if you are using this data source to, in the future, create a machine learning model, then you would indicate that and it will give you the option to create a target attribute where you again specify the type and indicate which of your variables you are going to be referencing and trying to predict. So you just select that and you can move on to a row identifier, which is optional. Basically that assigns a unique row ID for each row that you have. And we did not have any need for that. Next up, you actually begin creating the ML model. As you can tell, it's very straightforward. You go back to that Amazon machine learning page, and all you do is you hit Create New ML Model. So here, what you can do is, since you already have the data source created, you can just point right to that, and you name it, and basically set a bunch of variables. There is a default setting where they have everything selected already, such as here it says you can choose 70% for training and 30% for evaluating, much like we did in our other machine learning assignment. But if you want, you can customize that. You can also set the size of the model as well as the number of run-throughs that it does in order to generate better predictions. But again, at a cost. Those will take longer, and I guess that's the only downside. So at that point, you select Finish, and it begins processing. So it makes a new data source for whatever your training data is, and a new data source for all your evaluation data. And if you like, you can set that randomly or based on however your data is already listed. But yeah, so it starts training the model, and then it uses the next 30% or whatever you've specified to evaluate it. Now, the next part is the fun part, which is where everything is complete and the model is done being built and the evaluation is finished. So here you can look at the summary, and depending on which type of variable you were analyzing, that can either be, again, binary, numerical, categorical, or text. It has different analysis, and as you can see, it's very thorough. They have an AUC as well as a quality score, which is going to be explained a little bit later on, the details of that. But it compares it basically to the standard case, how good your model was at predicting based on the evaluation data. Lastly, you do have the option to create predictions, where if you have more data but without the actual variable that you're trying to predict already in there, then you can actually say, you can ask the service to try to predict what it thinks the results will be, and you can go based off that to try to generate new data.
Okay, so what we decided to do was take a large data set of criminals and use that information to predict different things about them. So specifically, we took a large data set of over 5,000 inmates, and each of these inmates have over 500 different variables about them. All this information was surveyed, collected all, put in one big data set. So what do these numbers mean? Well, each variable has different meaning. We have anywhere from, the offense, their sex, race, date of birth, marital status, their sentence in prison, all this information. And so what we decided to do was take their current offense, and basically we wanted to use Amazon machine learning to try and predict what their offense was. So what was their crime, using all this information, trying to guess what was their crime. So what we did was, obviously upload the data onto the S3 storage. Then we created a data source. And so this data source basically just tells us like a summary kind of all the information we just gave it. And so how the crime is represented is in these numbers. Each of these numbers represents a different crime, which we have a little reference here, which goes from murder, rape, robbery, hit and run, a bunch of different drugs, a bunch of different crimes. There's like 80 of them. So what we did is, or the data source basically summarizes, all right, well, there's this many people with that crime, blah, 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 this many people with that crime, etc. And this is going to be a categorical attribute. And so we want Amazon to predict this in a categorical way. Basically assigning, one crime to one number. That's what we want, not just like a range of numbers. So then we created a model. And so our model, we had an evaluation, scored it, which we could take a look at. And so we got a pretty good score on this, and we'll check it out right here. Basically, this chart is going to tell us basically all the predictions would happen, which is pretty good. So we had crime number 24 was basically guessed correct 90% of the time, and then it falsely predicted all these numbers, or all these different crimes. And so basically blue is really good, white bad, red worse. So we did pretty good. We get very much guessed, the crimes 90% correctly, 88, and it's looking pretty good. So overall, it pretty much gave us, a 90% predicting true on most of these. And this is what makes Amazon machine learning very interesting, because you can basically take large data sets up to the limit is like 1,000 different variables, and you can just load up a bunch of data and make predictions on basically whatever you need. And so the model we just did was a categorical model, and we did a couple others, which was we did 2 binaries and a numerical model. So we can quickly go over those. For our numerical one, what we decided to do was predict the inmate's sentence in prison. So based on whatever crime they did. So what we have here is 4 different columns, the sentence length in days, months, years. So we decided to just make another column because you can only have one target variable. So we decided to just make it the sentence length in days. So we just converted all these to days, added up in a separate column, and we made this other one, which is the other length. And this could be death sentence, life in prison, and other stuff. So what we decided to do is just for life in prison was just to take like a average life expectancy of like 80 years, subtract it from the inmate's age, and just say that as years in prison to make things a little bit easier. And we just said death sentence, we just assume 0 because they're dead. And so for that, we can take a look at our, so we upload a new data source for that, and it basically just summarizes, the days in prison for all the inmates. And then our model, take a look at the evaluation here, did pretty good, especially for a numerical model, basically just guessing the sentences for all these prisoners, and they got within a pretty good range. I mean, it looks pretty like a normalized curve, not far off like 100 days, which is pretty accurate. And then for other two we did was there were 2 binary models, which were we decided to check out the whether the inmate's sex based on the crimes, all this other information. So we tried to guess the sex, and obviously it's binary, male, female. And the other one was we tried to guess whether the crime was violent or not. And so out of all these crimes, we have murder through assault, rape, robbery. We decided the first 18 of these were violent. And so out of all these numbers in the violent crimes for all the inmates, we made a new column and decided, all right, if it's 1 through 18, we'll say it's violent. So we said 0. If they're greater than 18, we'll say 1. So that's how we made it binary. And so we'll take a look at those models real quick, or actually the data sources real quick. And so yeah, basically just summarizes the how many were male, how many are female, and same with the violent data sources, just summarizes our inputs. So we got that many violent, that many non-violent. And then we could check out the models we created. For the violent one, it didn't do as great on this one. It had a little trouble, but it still was considered good based on most applications. It got a decent score, and we can check out the performance. I mean, it's still pretty good. We got 78% accuracy, so 70% were true positives, true negatives, and only 22% were errors. So 97 false negatives, a couple hundred false positives, which is pretty good for a data set of over 5,000. And so our other model was the sex model, which was actually a really good performance. We'll take a look at that. And yeah, so I got an extremely good score, and the performance was really good. It got a 80% accuracy on the 30% testing data, and yeah, only 300 were errors out of the 30% of our 5,000. And so yeah, we got really good precision, like 99% precision, and 80% accuracy. So those are just like the couple things you could do with the models with categorical, numerical, binary, just basically making any kind of predictions that you want. We did not get to try out the text predictions, but that's another awesome tool that Amazon machine learning offers.
As you can tell, there are unlimited possibilities that can come from Amazon machine learning and its predictive capabilities. We can't wait to see what technologies and innovations come from it. Thank you.